Today in geometry we are going to talk about angle-pair relationships. Before we get too far into the lesson, there is some vocabulary that we need to learn so that it all makes sense. When we talk about complementary angles, we're talking about two angles that add together to a sum of 90 degrees. So an example of that would be an angle of 30 degrees and another angle of 60 degrees. Because 30 plus 60 is 90, we could call those two angles complementary. Supplementary angles are two angles that add together to be 180 degrees. Okay, so an example of that would be one angle that is 120 degrees with another angle that is 60 degrees. Those would be considered supplementary angles because 120 degrees plus 60 degrees is 180 degrees. Okay, now when we talk about adjacent angles have three characteristics. They must share a common vertex. We'll call this vertex A. They must share a common side. We'll call this side AC. We'll have this side be AB, and this can be AD. Okay, so these are adjacent angles because they share this common side, AC. They share a common vertex, A, but they don't overlap. They don't have any common interior points. So those are the three things that they must have. They must have a common vertex, a common side, and the third thing is no common interior points. They may not overlap. A linear pair. The base word of the linear is line, so we're looking for two angles or a pair of angles that make a line. Remember that a line has 180 degrees. So when we look at this line right here, we know that any straight line has 180 degrees. So if that line is cut into two angles, into a pair of angles, we have a linear pair whose sum of the degrees must equal 180 degrees. The last vocabulary word that we are going to look at today is called vertical angles. Vertical angles are angles that are straight across from each other. So if we look at this right here, we have, if this is angle 1 and this is angle 2, they're straight across from each other. Those are vertical angles. And we know that vertical angles are congruent. Okay, they equal each other. So in this case, angle 1 would equal angle 2. And then if we put another angle here and called it angle 3, angle 4 would be vertical to angle 3 and angle 4 would be vertical angles, and they would also be equal to each other. Let's identify some complementary angles here. We have several angles here. We have this small angle of BAC. Here's BAC, and it's 32 degrees. We have angle CAD, and that is 122 degrees. And we have another angle over here. Angle S is 58 degrees. And we also have this large angle right here, which is 122 degrees and 32 degrees put together, which would give us 154 degrees. Okay, so if we're going to look for a set of complementary angles, remember, complementary means that they are going to add together to be 90 degrees. If we look and we said angle CAB equals 32 degrees, and angle S equals 58 degrees, we could add those two things together, and that would give us 90 degrees. Therefore, angle CAB and angle S are complementary angles. Okay, also, now we're going to supplementary angles. Supplementary angles are angles that add together to be 180 degrees. Now, I'm going to ask you that on the quiz. I'm going to ask, what is a complementary angle? What is a supplementary angle? And you need to know that complementary angles are two angles that add together to give you 90 degrees. Supplementary angles are two angles that add together to give you 180 degrees. Okay, so if we look at angle DAC here, it tells us that that is 122 degrees, and angle S equals 58 degrees. If we were to add those two things together, we would get 180 degrees. And because they add together to give you 180, then they are supplementary. Let's review a little more about complementary and supplementary angles. In the first diagram, if we know that angle 1 and angle 2 are complementary angles, then we know that 2 has got to be the complement of angle 1. And so if angle 1 is 68, then angle 2 must equal 22 degrees, so that their sum is 90 degrees. When we look at the second diagram, if they tell you that angle 3 and angle 4 are supplementary angles, then we know that angle 3 must be supplementary to angle 4, which means they must add together to be 180 degrees. If angle 4 is 56 degrees, then angle 3 must equal 124 degrees, so that their sum is 180. Now to review a linear pair. If you have a line and it's broken into two separate angles, and you have a pair of them, that is a linear pair. So here we have that angle 1 would be a linear pair with angle 2, because when you put them together they make a line. In our second diagram for vertical angles, I want you to remember what we said on the first page, that vertical angles are straight across from each other and they are congruent to each other. So in this case, angle 3 would be vertical to angle 5, which means that angle 3 is vertical. We also know that it is congruent to angle 5. That means it has the same measure. And we would know that angle 4 is vertical to angle 6, which means that they would be congruent. Angle 4 is congruent to angle 6. Vertical angles are straight across from each other and they are congruent. If we know that two angles are a linear pair, like we do here, 5x and 1x, then we can solve for what x is and solve for what each of the angle measures would be. A linear pair makes a line, so we know that the sum of the two angles must equal 180 degrees. So we can say that 5x plus 1x equals 180. So we will have 6x equals 180. Now we will divide both sides by 6, and we will get that x equals 30. If we know that x equals 30, then this angle here is x, therefore it must equal 30 degrees. If the larger angle is 5x, then that means 5 times 30. That would have to equal 150 degrees. And you better double check and make sure that when you add those two angles together, they do for sure make 180 degrees. And 150 plus 30 is 180, so it's all good. Let's do one last review problem. If you are given a diagram such as this one, and you are told to find the measure of angle DEG and the measure of angle GEF. Okay, DEG is this angle right here that they have labeled as 6x, and GEF is this angle that they have measured as 4x. Well, let's figure out a few things. How can we do that? We know that we have this line right here, and it is 180 degrees. This square in this corner means that this is 90, which means that these two angles on this side must also equal 90. So we know that 6x plus 4x must equal 90 degrees, because we know that the two together have to be 90. So we will have that 6x plus 4x has to equal 90 degrees. We will combine like terms. 6x plus 4x gives you 10x equals 90 degrees. So now we will divide both sides by 10, and we get x equals 9. Okay, now we're going to take that x equals 9 and substitute it back in for 6x and 4x, and be able to find the measure of angle DEG and the measure of angle GEF. Well, here's DEG. And so if we put 9 in for x, we have 6 times 9 is 54. So we will get the measure of angle DEG equals 54 degrees. Now we also need the measure of angle GEF. And the measure of GEF is 4x, or 4 times 9, and that is 36 degrees. And if you add those two things up, you get that equals 90 degrees. So our solution is correct.